Welcome back. I've decided to go through the fonts section of Handmade, and then I think there's a bit, it goes a bit into about visual debugging. Sounds interesting. Have a look into that too. Where is it? .62. Yep, go through the font stuff. Yeah, and then look at the debug infrastructure. Okay, this looks good. It's quite comprehensive. I think up to about, what is it? Day 209. Link buffer debug data. Consolidating debug data. Yeah, it's quite a few. This is good news.
The font file ends up being at the end of the day is typically something like a Unicode. Oh, and by the way, I didn't actually say it. They are called, this sort of entries into the Unicode table, they are called code points. So when you hear someone say a Unicode code point, they are referring to that numerical slot that has been reserved for this glyph. Slot 63,452, all right, which corresponds to whatever glyph, that's like a Unicode code point. That's typically what that phrase is used to describe, right? Yeah. So anyway, so that's typically what ends up being in something like a font file, is it will be something like, here is an outline of a T, here is the Unicode code point, right, that describes which glyph I'm talking about. So now the code knows, oh, okay, that's an English letter T. Okay, I get it, right? Or that's the Chinese symbol for meat, right? I get it. So now it's basically like a way of bridging that gap of, I've just got a bunch of outlines in this file. I need some way of telling you, what do they actually mean to a human who spoke this language? What do they mean? And that's what it tells you, right? So the code point is almost all the information we need. Almost all, right? We've got a glyph, we've got the code point, but it's not quite enough yet to actually constitute a useful font. And the reason is because we don't actually know how to start assembling multiple characters together into words. So let me tell you a little bit about basic typography here. I'm not going to harp on it because Handmade Hero is not about text, so we don't have to be expert typographers to do the implementation of the font system in Handmade Hero, right? If you were doing a game that was all about fonts, you would want to be an expert typographer, certainly. But I'll give you a little bit of the basics. So in typography, right, there's basically everything is about sort of the solids and the empty spaces and the solids of the fonts, the shapes they make and how they like interrelate. They spend a tremendous amount of time thinking all of this through. And they have a bunch of properties about fonts that they think about. So for example, you might take the letter G, and if you wanted to talk about that shape, there's a number of things that you could talk about. You could talk about the fact that, for example, the G, unlike the H in a standard font, you might say that the G has a descender in typography speak, which is this bit that comes below sort of the line here. And then you might say that the H had like an ascender, which is something that kind of comes up above this, right? There's ways that they describe these things. But this line right here is often referred to as a baseline, right? And so one of the things that is described oftentimes in a font file is what is that baseline and what are the characters how does the character glyph relate to that, right? How does the character glyph get positioned relative to the baseline might be a piece of information that's necessary in the font file, right? Similarly, something like what is the maximum descender height, right? Like of all of the characters in this font, what's the one that goes down the furthest? Of all of the ascenders, what's the one that goes up the highest? And again, these are things to allow you to know when you're going to go use this font, what is its general span vertically, and what is the actual region that it actually typically uses, right? What is, another one would be, what's the line height? Meaning, what did the fontographer who created this font envision being the spacing between lines in a normal scenario? Like, you know, if I was going to put the next character down here, where would it be, right? So you start to have some information like that. But most important of all, and unfortunately a lot of fonts just don't even do this very well, but ideally speaking, your font file has a thing called kerning information. And what kerning is a way of understanding how to adjust the positioning of letters horizontally based on which pair of letters you're talking about, okay? And so to understand...
Yeah, I have noticed this. Like some fonts, the spacing is not always the same between letters.
And the difference between these things, you first have to sort of think of the difference between mono and proportional, right, fonts, which you've probably seen before, right? A mono or monospaced might be the more appropriate term, right? Monospaced font. A monospaced font is the old school kind that was on typewriters and terminals when they did not have the level of sophistication necessary to advance the right position by a variable number of pixels or space on the typed page or whatever, right? And so what happened was a font just had to have an equal amount of space. So if I had a G and I had an I, they both had to take up the exact same amount of space width-wise, which looks pretty dumb, because there's this giant gap on either side of the I, right? Because if you were to make it the size that you would normally want to make the I, the G would like sort of overflow it, right? So you kind of had to adjust it to make it some kind of uncomfortable size that was too big for some letters and too small for others, but you know, it kind of was like the best you could do, right? And so as you typed away, it would just move by that amount, and you would...
I didn't know that's what kerning was. I've heard it a few times. It's the first time I actually understood what it means. That's pretty cool.
You would end up with something like the word gill would look something like that, right? Where the spacing was consistent between each of the center points. And it would look really stupid because the way that fontographers who laid it out in lead would have done it would be like that, which looks a lot more natural and is easier to use, and also helps articulate the difference between spaces in between letters, which are not what you want to focus on when you're reading, and spaces in between words, which you do, because it helps you tell, right? Words are recognized kind of as a chunk, and so you want them to group together cleanly and not have the person be confused about what is a space and what is the word, right? That's not a good thing from a typography standpoint. Okay. So once we had the sophistication to do so, proportional fonts were definitely a preferred thing to do because they were certainly better than monospaced fonts for readability, and so systems wanted to support that so they could produce better looking output that was more on par with what typographers were able to do, because they had refined that in sort of the printing press style, right? They were making characters that were different sizes already. And so what we wanted to do is we wanted to, in computing, we want to be able to do that same sort of stuff. And so what we can do is we can say, okay, now whenever we draw a glyph, when we draw the next glyph, we'll just sort of have some understanding of how far to go. But if you think about it, it's actually a pretty tricky problem because the actual distance you might want to go is not necessarily constant depending on the letter, right? A naive proportional font implementation just says, okay, for every letter, there's a certain distance I will advance, right? And that's fine in general, and it solves our gill problem to some degree, right? But what it doesn't solve, and what's sort of a level above that, right, is the concept that depending on which two letters you were putting back to back, you might choose a different amount of space. And to give you sort of an example of how that works, right? Suppose I was to take the letter G and the letter J, right? And I was going to put those two characters next to each other. Well, I would probably want to space them so that there's like a reasonable amount of space here, which would leave kind of more space there, right? So when I'm thinking about how close this J should be to something, I have to consider that, right? It's going to be a little bit different there. Now, on the other hand, if I had an I, right, and a J, those can go much closer together because the J descender can easily overlap the I, right? The same thing would be true in the forward direction. That was kind of a backwards looking kerning example. The same would be true in a different example. If I have an F, right, and I'm going to follow it by an H, right? I guess I drew my F kind of poorly. If I have an F like that, right, and I'm going to follow it by an H that goes all the way up, right, like so, I would probably have to space these so that, it looks something like that, which leaves a fair bit of space here, but, it's because of the closeness there, right? Again, on the other hand, if it was an I could probably snuggle that I in right next to it. In fact, this is so common, there's even a thing called a ligature, which we don't really have to cover in Handmade Hero, but there's a thing called a ligature, which is actually when the fontographer creates a unified glyph designed to represent F and I together because it's so common, and oftentimes they'll do it. It looks like that. It's like a combination of an F and an I, right? So yeah, but point being...
Interesting. I didn't know that's what ligature was. I just thought it meant for symbols.
The distance between letters can be highly dependent on the pair of letters, not just the letter that came first and advancing by a certain fixed amount. And so that's where kerning comes in, which is the idea of modifying the inter-character spacing to account for that pairwise difference. And so what you end up having is you have another lookup table in this font file, or I shouldn't say a lookup table because it's just information encoding in the font file, right? Which would be something like, a simple example would be something like this. It would say, a character A, character B, or I should use something else, character 1 and character 2. I don't know what to say. I can't use anything because any glyph is going to be something that could be in there. Character A and character B, and then a kerning value. So it would say like, okay, if there's a G and a J that are back to back, I want you to do, the spacing is 5. If it's instead an I and a J are back to back, I want the spacing to be less. It's going to be a 1, whatever. And oftentimes the way that kerning is represented for encoding reasons is that typically it's actually not the total amount of spacing. That's really not what they tend to encode. Kerning typically refers to the delta between the normal spacing and this pair spacing. So typically what will happen is you'll say, okay, there's a normal spacing. There's a normal advancement, right, for a G. So in the table where the fonts are encoded, we say G advances 10 units, right? That's what G advances. And the kerning for GJ would say, okay, you were going to advance 10, now subtract like 5 from it. So you actually just do 5. So instead of encoding the 5, it encodes a negative 5, which is the delta from the G's spacing to the, right? That's just how that goes.
Okay.
Right.
That makes sense.
The idea behind that, I believe, is to save space, right? Because if I just encode one, remember this is an n squared thing, right? This is n squared because if I was to encode the kerning for every single font pair, I would basically have, a times, like however many there are, like if there's n glyphs, I would have n times n entries in this table. And so I think what they do is the reason they don't just describe the spacing entirely by an n times n table is because I think they were trying to say, well, it'd be more efficient to say, let's just describe a default spacing that goes after every character, and then we'll just put an entry in the table for when we are going to modify that. And then I think that's why it ended up being, kerning ended up kind of being by default defined as this thing that adjusts a default spacing, right? So that's how it goes. So that's how much time we got left. All right, so we got about 20 minutes left. So 20 minutes left. We got 25 minutes left. So that's what a font file is, right? A font file, and a font in general, you might say, is something that declares all of these guys, right? It declares all these glyphs. It declares some fundamental things that we might have, like what are often called metrics of the font metrics, which are basically saying, like where's the baseline, descenders, ascenders, some set of numbers that gives me a little bit of an idea about how the font is laid out. And then typically also a kerning table, which allows me to sort of know how I might want to adjust the spacing of these fonts to make them look the way the fontographer intended. Unfortunately, a lot of times these tables are awful. The fontographer does a really lousy job, and that annoys me to no end, but what are you going to do? And then finally, the thing that font files have oftentimes is they have something called hinting as well. We don't really probably care very much about hinting, but what hinting is if you're trying to make fonts that appear very, very tiny, then there are some things that you don't really want to do. So for example, if you're talking about a font that was going to become rasterized on a very, very small scale. So let's make a little grid here that we're going to rasterize, right? 0, 1, 2, 3, 4, 5, 6, 7. I'm going to make a little 8x8 guy here. 0, 1, 2, 3, 4, 5, 6, 7. Okay. So, if I was going to rasterize a font on here, one of the things that can easily happen is if you're dealing with a proportional font, again, it's resolution independent. It doesn't know what's going on. So we take something like that example I gave you where you have the T, and what we end up with is some really bad scenario where the way the T lines up in our grid will look like this. Okay. Well, okay, maybe not exactly like that. Try that. Okay. Now what you can see here is that our T is only 1 pixel thick. But because of the way that it happened to line up on the grid, it is now a 1/2 pixel thick in this row and a 1/2 pixel thick in this row. Now if we were to render that even with anti-alias rendering, what we would get is a very wide gray T, right? Because it's like halfway in all over the place.
Right.
Right? And that's not what you want for readability. What you want is this thing to snap to the actual pixels, and you wanted to draw the T like this because that would have been what was actually the most legible, right? Oops, I should not quite do that. I didn't mean to do that one. There we go. Right? You want to draw the T like this, or did I mean to do that? 1, 2, 3, 1, 2. Yes. Okay. Sorry. Like that. So yeah, that is what you would prefer to do. And so what hinting was a way of describing the fact that you wanted to do this to certain letters, like stems and stuff, to try and line them up with pixels so that you wouldn't get that kind of effect. It's not really relevant anymore on super high-res displays, so, Retina display or whatever craziness. When the pixel count gets high enough, you're always dealing with enough pixels that it doesn't matter. But when you're talking about, an 8x8 font or something like this, it starts to matter. So there you go. So that's typically what's found in a font file. And our job now is we want to build something that will allow us to take these font files, right, take fonts, and be able to use them in Handmade Hero. And we have a number of ways that we could do that, right? And so we kind of want to think about what are the ways that we could do that, what's going to be most efficient for us, and I'll kind of propose how I think we should probably tackle it because, again, Handmade Hero doesn't have a lot of need for fonts. It's not a font-centric game. So it should probably do something with fonts that's relatively easy and is fast to render, like isn't going to be some kind of concern for us where we're spending all of our time thinking about how our fonts are working, right? Okay. So option 1 is we could actually load, TTF files or something, right? We could actually rasterize the fonts directly, okay? And what would that look like, right? Well, what that would look like is we'd have 2 options for that. One would be if we were in a relatively sane way of doing it, right? Is we would load in the font glyphs, right? So we've got that T. We would load in the font glyphs. We would turn these into triangles using a thing where this is typically a process called tessellation, which we haven't talked about because we don't really need to use it in our game at all. But we would turn these into triangles, right? And then we would actually have like an outline version of that font, right? That we could then use to render things. Now, of course, there's a problem. There's a caveat there, which is if we were to do that just once and just use the fonts in this format, we would have a problem when we went to do like our S's, which is that we'd have to pick some discretization of the S. Like we'd have to pick some degree of fidelity when we turned it into triangles. And then if we zoomed in too much on the S, we would be able to see that this part was a line and not a curve like it was supposed to be, right? So that's one thing we could do. But of course, we could always fix that by tessellating dynamically at runtime and saying, okay, maybe we write a really fast tessellator, and we then say, okay, how big did you want the S? We'll tessellate it more or less, depending on how large it is, blah, 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 right? So we could load TTF and tessellate. That's one option. Two is we could load TTF and implicitly rasterize. Again, not something we really have covered too much on Handmade Hero, but we actually implemented it already. We actually did one. And when did we do that, right? Well, if you remember, when we did our triangle, our quad fill, remember how we did that? What we did is we said our quad was a series of edges, right? It was a series of directed edges. And what we said was a pixel, we like figured out a bounding box for our quad. And we said a pixel in here is going to be filled by the quad if it is included inside all the edges, right? That was what we said. You remember this, right?
No, because I think we skipped past it.
Well, we could go right. The same kind of, that's called implicit rasterization. It's basically you have some function you can evaluate. Implicit, I've talked about implicit, explicit a little bit. Implicit is f of xy, some function that we put in xy and it tells us like, you know, some value out that's like, for example, whether it's included, right? Whereas explicit is like something where I feed in some parameter and I get out the xy of it. So like if you know, you could imagine like drawing a line, you feed in successive values of t and you get points along the line, right? So implicit rasterization is when we're talking about being able to step through pixels and say, is this in the shape or isn't it, right? And how do I fill it, right? So we could do that for our fonts. We could do that by saying we've got these Bezier curves, right, whatever they are, for our S, and we're actually going to do an implicit rasterizer that says for any point, we can ask the question, is it inside or outside of these curves? We could do that. You typically do that with what's called a line test, where you look to see how many times you have crossed over shapes that are in your set, right? And if you've only crossed over, you know, going in one direction, if you've only crossed over one line, it means that you're inside, right? Whereas if you've crossed over two lines, you're outside, right? And it's odd versus even, right? Because you could do, if you did something here, it's like I could go in, out, right? So it's basically like if I've crossed over an odd number of times, I'm inside the shape. If I've crossed over an even number of times, I'm outside of it, right? We could write that. And the benefit of that is that just works at any resolution, right? No matter how you scale or shrink or warp or do whatever you want to the S, we would always have a perfectly smooth curve going around the S, right? So that's another one. But I don't really think we need any of these, right? These are overkill. These are drastically overkill. They're overkill for 99.999% of all games, right? Because most games just don't have that kind of an unpredictable, heavy reliance on font shapes. Most games know their target resolution or thereabouts, or a couple of them. Most games know how big the fonts will generally be appearing on screen. So most of the time, making a system that is capable of doing this much work with the fonts just simply isn't that important. And you're wasting your time if you go hog wild on it. It's time you could have spent doing some other feature in the game, right? And so typically you go with option 3, which is pre-rasterized fonts, right? And the nice part about pre-rasterized fonts is basically pre-rasterizing fonts turns fonts into something that your game can already handle, right? We already know we can blit bitmaps to the screen. We even know we can transform and scale them, right? We've done that with our hero sprites and the sprites for the background and all the other stuff, right? We've built good systems for doing that. And so the nice part about pre-rasterized fonts, right, is pre-rasterized fonts turns fonts into a problem that we already solved. And the way that that works is if you're trying to do pre-rasterized fonts, what we say is let's build bitmaps that capture the font at a certain resolution. We'll say, okay, for Handmade Hero, here's our target resolution, right? We want 1920 by 1080 or something, right? And we want our fonts to show up roughly this size. So, we want them to be, 40 pixels high. So let's just rasterize the font out at 40 pixels high. We'll save the results of that rasterization into a set of bitmaps or a single bitmap where they're like packed together, whatever, right? And then when we want to actually draw these, we will simply put them back on the screen, right? We will simply blit from the bitmap just like we blit from everything else. Very straightforward, right? Nothing crazy happening. Okay, so that's a lot easier and a lot more straightforward, and it also has the nice aspect of no matter how complex the thing is that pre-rasterizes the fonts, it doesn't matter because it's not happening at runtime, right? Here we would have had to start thinking like, oh, what's the performance considerations of this, and is it going to start impacting my frame rate if whatever, like, because there's complexity here. Here we know that it's just going through the standard bitmap blitting path, so I pretty much know exactly everything I need to know about it. And no matter how complicated the glyph is, it doesn't change. It's just however big it appears on screen is how much it costs. That's it, right? It's just like any other bitmap. There's no magic to it. And so we can rasterize any font we want that way, no matter how crazy it is, and that's fine. So how do we do this, right? How do we do pre-rasterized fonts? Well, you typically...
I think just go to the next episode.
Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream on Twitch. No engines, no libraries, although I say that every day, and in truth, I did also say that our asset processor, since it is not part of the game, could use libraries. I said I do not have a problem having that use libraries. And the reason that I mentioned that is because we do actually have a choice today of using a library. And because people wrote in on Twitter and sort of said this, they were saying, since the asset processor is allowed to use libraries, and I said that, could we use a library there for opening the fonts? And I am considering that. So basically, there's two ways that we can really do it in the asset processor. One is that we just get the fonts from Windows, right? And the other is that we use some kind of library. Now, originally my assumption was I'd just show you how to get them from Windows because, well, it's very direct, and, when you're running the asset processor on Windows, you can just extract the fonts, and whatever other platform you would use, Linux or something, has a similar API you could use to extract the fonts, and off you go, right? But I don't know. I thought about it when people were saying maybe you should use a library here. I thought about it, and the thing that I thought of was people always ask me on the stream all the time, if you were going to use a library, what libraries would you use, right? And I always say the STB libraries. And so, I don't know. My thinking was I could decide to use a library here to show you how to use an STB library, because as I have said over and over again on the stream, if I was going to use a library, the libraries that I would use would be the STB libraries. They're libraries written by Sean Barrett. They're designed with a game programmer in mind. They're written in a very convenient way to integrate into your product, and so I don't know. So I don't know if people have strong feelings on that one way or the other, so I thought maybe what I'd do today was show you how to get the fonts with an STB library, show you how to use one of those libraries because they are libraries that I recommend using. And this would pretty much be our only time when we could do this because, like I said before, in the actual game code, I don't want to use any libraries, right? That's just kind of a rule for the game itself. It's just an arbitrary rule, it's true, but it's just part of the thing that I wanted to do with the series was we write everything in the game from scratch, so the entire code for the game is completely there and written by us, right? So I don't know. So probably what I'll do is we'll do that today because it seemed like a reasonable request from people. And then if it ends up bothering people, we can just show also how to do it directly through Windows or something like that. But we'll see. So that's what I would say. So maybe that's what we'll do today. That seemed like a reasonable request, and it seemed like something we could do. And it has the fringe benefit of if somebody wanted to use this library in their actual game, now they would know how to do it, and they would know how to use all the STB libraries really, because they all kind of work the same way, and they're a great set of libraries that is really easy for you to use. Even if you are very meticulous about low-level things like I am, they are libraries that won't cause you pain and suffering like a lot of them will. So, if you're going to do that, how would you do that? If you're going to use STB libraries, you would search like this, right? You search for STB libraries, and you get them here. And you can go to this STB page, right? It's nothing/STB. And he's got all of these libraries in here. Now, several of these libraries are pretty darn useful. Like STB image is like a great way to like quickly add image loading to your code, right? So if you take a look at it here, it's like this one file, right? And it reads like a bunch of stuff, right? It reads like JPEG, PNG, BMAP, PSD, TG, right? And it doesn't read like the complete spec of all of them usually. It just reads the part that game developers usually care about, right? So this is just like when people ask me if you were going to use libraries, which ones would you use? These would be the ones that I would recommend using, or at least it'd be the place that I would recommend looking first, because if it does the thing that you want, these are probably the libraries that will cause you the least pain and suffering. They are also public domain, so there is no restrictions on using them. You can redistribute them. You don't have to do anything in particular on your credit screen for them. It's purely like, it's code that's free for you to use in every possible way. And, it would be nice to probably to thank Sean Barrett if you ship one of them, but, you're not even obligated to do that. And so you can see a little description here that talks about all the different ones. And the one that you would be interested in particular, if you wanted to do the font stuff, is STB TrueType, right? Which is this one here. And STB TrueType is a library that it literally does exactly the thing that we want, which is it is a TrueType font rasterizer, right? It literally does exactly the thing that I said our asset processor would want.
Wonder if it works on STB libraries. Or STDB. They have an easy font. Font printing frame rate. So here's a sample programs. Points of pixels, call scale for pixel height. Displaying a character. Compute the bounding box of a character. It will contain signed values relative to current point. Right, and the character should be displayed in the rectangle form. Current position, baseline, current position, baseline. Advancing for the next character, call glyph h metrics and compute current point plus equals advance times advance. SF times advance. Okay. Use the function with subpixel at the end to allow your characters to have subpixel positioning. System uses the raw data found in the .ttf file without changing it, without building auxiliary data structures. Assuming you're caching the bitmaps or glyph shapes, this shouldn't be a big deal. Sample programs. TTB buffer. Temp bitmap. TTF buffer, sorry. Okay, you open the font file. Pick font bitmap. Right. And free TTF buffer at this point. Right, because you don't need. It's only used for the first read. Fine texture, text image 2D. What are these values? Oh, they must be defined in. Oh, this is the header bar. Doesn't seem too bad, to be honest.
Okay. So the structure of one of these libraries is very straightforward. There is one file. He ships it as an H file, right? So you can see all of these are H files. And the way that they work, you can look inside one, right? STB true type. The way that they work is inside the H file, there's actually a pound define that you pound define to say whether you want the implementation or just the header. So you actually, like, it's actually two files in one. It's sort of like the H and the CPP file, or in this case C file, wrapped up into one file. So you don't need an H and a CPP, you just need the one file. And then what you do is, if you want the actual implementation, the part that's the C file, the .c file, then you pound define typically something like this. And if you don't want that, you just don't define it. And then it acts like a normal H file, because all of the actual implementation, like all of this stuff, won't get compiled in. Right? You can kind of see, if I come back to it here, where would that be? Where is the ifdef? Almost there.
And is that a way? There's something in the standard library for font. Simplified font package. So far, it's only STB true type H ported to Zig, but I think it'd be nice to all past if there's interest. Okay, I think I could just use this.
Where are we? Here it is. This ifdef, right, kills everything after it if you don't define STB true type implementation. So if you don't define STB true type implementation, so yeah, so all I guess you'd have to do is click on raw, click on save as. Sorry to those of you who are GitHub experts, that is probably not the recommended way, but you know, those of us who are GitHub impaired. So if we're going to download this guy and save it in here, right? Now we've got STB true type. And like I said, the big difference between STB true type libraries and the reason why I feel like they are, you know, something that I consider for my own coding, unlike a lot of libraries, is because they're just really sensibly made, and they're really easy to maintain and keep using in your source code because there's just one file and it integrates really cleanly. So for example, right, if we wanted to in handmade.cpp, right, we could go ahead here and actually just do some rendering with STB true type. Let's say we wanted to kind of put it in here, and I'm just going to like drop it right in the middle of some code here as an example. And then we'll go into the asset processor, and I'll show you how we would integrate it in. So if you wanted to do it, you would literally, we could just do true type .h. And like I said, if you take a look at how that works, there's an STB true type implementation, right? In here, you would pound define that first, and you would set that to 1 or something. You would like just have to pound define it, right? So if you were going to do that, that basically says I want the implementation as well, and then you just compile. And like you can see, like that is it, right? And I really want to underscore this. Like this is why this is a big deal. Okay, we didn't have to download 50,000 files. We didn't have to deal with someone's make system. We didn't have to figure out how they all link together or what compile time switches they need or anything else. It's like I just included Sean Barrett's TrueType font rasterizer in my game with 2 lines of code, right? And it just worked. That's a really big deal, and nobody else pretty much does this. There are a few rare exceptions of people who have followed his lead, but that is a pretty big deal. And it goes a long way towards giving me the confidence that if I use this thing, I can maintain it easily.
Okay, I mean, if I were to use a check, oh, you can hear the rain in the background. Weird. How would I install my chat? Just ignore the rain in the background. Can't remember how you include dependencies in Zig. One file. Zig install dependency. Can't remember the last time I added a dependency. Oh, it was Zig fetch. Seems easy enough. Oh, did I say git? Should be zig. That the latest commit? Yep. True type. True type.zig. I think in the wrong file. I think you don't need this. Okay, that worked. True type.load. No module name true type available within root. It is quite loud outside. Over for the package. Hang on, I missed. And this should be .zig. Still doesn't find it. Crew type. What does I remember if it's an external dependency? I think I know why, because I removed link external library somewhere here. Have I added a dependency to any project before? Yes. And look at build.zig. Oh no, wrong project. Get all of this. So now, yep, read on dependency, name and arguments. Okay. Okay, now I can find it. Okay, pretty cool. Okay, now I need to include a font. How do I... Just get the fonts from here. Let's get the first one. Can't remember how I downloaded these fonts. You could just find this one. Need the TTF italic. Get these. After it loads the window. Yeah. And did you embed a file? Embed file. I just renamed this to What do you do with to see if it works? Actually, don't need to. What did I call the file? OpenSons.tdf. Wait, let me just oh, because I think it might be an older example. Standard out. Check IO. I'll just file the file. Get standard. That's weird. Why is it not defined? Just write it to file, guess. How would it would write to the standard out file? Okay, let me just get rid of that. How is that even working? Guess we gotta find the standard out. Hang on, I could just put it printed to the window. No, 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 no. I do have it in the example. Never used the standard out. File dot standard out. Mm, uh, buffer. Oh, what am I missing? What do you do with the buffer? Does it feel so complicated? File not found. That's a different problem. What is the file that I'm looking for? Oh yes, because I think I need a folder. Forgot what it was called. Playback and game source. Oh, not file, sorry. Playback. Or was it game source? What did I call the folder? Yep. What's missing? I can't find. Maybe it's the glyph. Let me try just regular text. Okay, so I can't find it. What's the error? Is it the space? Okay, but I think I can figure that out later. So at least the font loads. And it's able to find the glyph. I gotta figure out how to print it to the window. Index. Well, there's a few things. Text to window, and then how the fuck does standard out work? Gotta figure that out as well. I feel kind of stupid not being able to write the standard out. We can close this, don't need that, don't need that. There's some documentation. Guess there's only one file, I could just look into it. Right, this is okay, it's true type.
So if I go into this is a function that basically generates a bitmap for a given code point, a given Unicode code point, right? And so what I'm going to do is I'm just going to make a little function here, right? Internal, void. I'm just going to make a little function here that does this exact thing, right? So here is the function that I want to call. It's called stb init font. We need to give it a place to store the font information, which is just gets declared on the stack. This is stb tt font info. You pass an address to that. And then I need some kind of a buffer, right, into which it will dump that font information, right? I'm sorry, not dump that, into which, or I should say from which it will read that font information, right? So this would be the font file itself. Now, we already have a way to do this in Handmade Hero, right? We have the stuff in Handmade Platform that's like debug, read entire file, right? We've got this thing right here. So we actually have a way of pretty quickly doing exactly what STB wants us to do. And again, you know, just not to extol Sean's virtues too extensively here, but again, it's set up exactly the way I want. He's not forcing me to pass him a file handle. He's not forcing me to pass him a file name. He's assuming that I already have ways to read files and that I'm going to want to read files the way I read files. So he just takes a memory buffer of the file. That's exactly what I want, right? It's exactly what I want. It minimizes dependencies. It makes it so that I don't have to work around him. He's working around me, right? And that's really great. Again, another sign of an intelligently made library. It doesn't force its file I/O on you, right? So I can do this, right? I can read the file. So here's our TTF file. I can say I want to take platform, debug, read entire file. And then I can just pass it some true type font name, right? So I don't know what true type font we want to read, but I can, for example, pick one out of Windows. In here, you can see a giant set of fonts, and Arial.ttf is almost always there. So I can perhaps just say we will use Arial for the time being, right? So I will go ahead and do debug read entire file to read out this font file. And then after that font file is read, I will just pass the entire thing to Sean, right? So I'll say, hey, Sean, here's the contents of that file. Work your magic. And that is it. Now, get font offset for index, I believe.
I can get rid of this example. Now. And I just start from scratch. I do think I can read from file too. Doesn't need to be embedded.
Is just a thing. You know what? To be honest with you, I don't really know what that does. I don't remember. So let's see what that does. Init font. Let's see here. Init font takes an offset into the data. Given an offset into the file that defines a font, this function builds the necessary cache info for the rest of the system. You must allocate the STB font yourself. Okay. So probably this is just if there's multiple fonts in a file, I would say. So stbtt get font offset for index. I believe that is what that does. Each EF file, TTC file, may have more than one font. Each font has a sequential index number starting from 0. Call this function to get.
I'll continue from this tomorrow. From here tomorrow, sorry. It was a bit of a stumble and tumble and a rumble. But at least got the font working. And now I gotta split this off the screen onto the window. I don't care about std out for now. Or use system. Hey Amberly 6559. It's working on this in Zig. I think you're a lot further than me though. I finished the Windows platform layer. And now I'm trying to port to Linux. Hey, sorry, I missed your message. Oh no, I didn't. You sent it. Yeah, I also just finished the platform layer stuff. I think up to episode 25. And I jumped ahead to the font section because I don't want to build a game. I want to build a debugger. So I think the next step was to figure out how to get fonts printed onto the window. Looks side only has the beginning rendering and keyboard gamepad input. Again, oh, I think you use tech in Handmade Linux, like the one that's on the website. I think I did see it. It was using STL, and I didn't want to use STL. So I've used X11 instead. Directly. And it wasn't too hard. In the STL, well, in the Linux port for Handmade, it says STL can be buggy and hard to use. Sorry, X11 can be. Yeah. Yeah, it's not too hard. I think I did it on stream. It took me about, well, twice as much time. I think it took me about 50 days to get 25 days done. I did it the window. Yeah, Wayland is a good option too. I think it's a newer option, so it might be better. And for the audio, maybe I still have it handmade. Yeah, for the audio, I just use Pulse Audio. And simple one is pretty simple. Yeah, I think that's how I did it. It's not that hard. You get it working pretty quickly. Wayland is handling my window and keyboard input, and the Linux EVDev API is handling gamepad input. Yeah, I didn't do the gamepad because I didn't have one here. But I did the keyboard. Yeah, I think I tried ALSA first, but I noticed when I was debugging it that it's called Impulse Audio API, or like if Pulse Audio was getting called. So I just used Pulse Audio directly. I think Pipewire might be the newer library compared to Pulse Audio. And for keyboard, yeah, I use it through X11. I think it's key press. Yeah, it comes through X11. You try Pulse Audio, they have a Pulse Audio Simple. You could try that one. It's a lot easier. Although the async one is not too bad either. But I didn't manage to get it to work. The only caveat with the simple one is it's a blocking operation. So I just ran it in a separate thread. But yeah, but the rest is fine. Okay. Don't even use this. Alright, thank you for hanging out. As always, I'm gonna call it a day there. It was a bit of a slow day. Didn't really get much done. It's fine. Alright, I'll see you back here. What's tomorrow? Friday. Yeah, I'll see you back here tomorrow.